For this lesson, we're going to talk about absolute value inequalities. So here I'm starting with the absolute value of x is less than 5. In the previous lesson, it was the absolute value of x was equals. So here I'm just throwing in like a less than, maybe a greater than or equal to. The good news is we can answer these completely from the graph, provided that you know where the two graphs are equal to each other. So by that I mean, starting with the absolute value of x is less than 5, I'm going to mark down where I know they're equal. So we had two solutions last time. We had 5 and we had negative 5. And we can mark these on the graph as well. Here's where the 2 points meet. One spot was at negative 5 and positive 5 for x. So what I'm looking for in my graph is, where's the absolute value lower than 5? So again, the way I graphed this in Desmos was for y1, my first equation, I just put in 5. And then for y2, so this one was in red, for y2, I put in the absolute value of x. I want to know, where is this graph have a lower y value than this graph? And the good news is the answer has only two possibilities. That's either going to be between our two solutions, or it's going to be on the outside of my two solutions. So it's got to be like one of these two regions. So I'm going to kind of trace along the graph and see what happens. So starting on the far left, here's the absolute value of x. If I compare this portion to the other graph, which is 5, it's very clear that, okay, well, the absolute value function is above, it's actually greater than 5. So I know I don't want to use this portion of the graph at all. So I'm traveling along the graph and the absolute value is greater than 5, but then I come to a place where they're equal. And once you pass over this point, okay, so we're still on the absolute value, but the thing to notice is this portion of the graph is less than this y equals 5 graph. This tells me what the answer to the inequality is. Everything from negative 5 to positive 5, not including those two numbers, is where this function, the absolute value of x, is lower than this other function, which is 5. So the answer to the question is this interval from negative 5 to 5. So this here would be the answer to this very first absolute value inequality. So it's kind of strange that you don't have to do any other work, but once you know where the two graphs are equal, you can go to your graph. You're like, okay, it's this spot and this spot. I'm either between those two values or I have to be on the outside of those two values. I decided that we were using the numbers between negative 5 and 5 because that's where the absolute value was less than 5. So you could have a different inequality. You could have, let's say, where's the absolute value of x now greater than 5? But you still would address this the same way. I know where the two graphs are equal. I want to know, where is this function now above this function? So traveling on the graph, here's the absolute value of x compared to this portion, which is 5. So it's now this spot that is greater than, or in fact equal to, once I get to this location here. That means the absolute value of x greater than or equal to 5 has to be these x values here. So I could even start by listing those. That was everything from negative infinity to negative 5, and including it. So you continue to travel on the graph. Okay, now we're at a portion where the absolute value drops below 5. So I know I don't want to include any of the x values for these points. But then we get to a spot where it's equal again at 5. And if we move to the right, now the absolute value is above 5 again. So this means starting at 5 and going towards positive infinity, I want to include all those numbers as well. So you also get everything from 5 to infinity. I'll put a U for union. I'm taking both of those pieces together. But for this other inequality, I use the outside portion of the graph. So like I said, there's two different possibilities for an equation like less than 5, or in this case, greater than or equal to 5. You find your solutions, and it's got to be either between them, we got this, or it's on the outside of those two numbers, and our expression looked like this. So again, now looking at something just slightly more complicated, I have the absolute value of 2x plus 1 is equal to, is less than 5. In the previous lesson, we figured out where the two graphs were equal. So we noted that it was, well, it's here and here. I can see on the graph that the values are -3 and 2, but I'll list them over here as well. We figured this out first. I knew that x equals -3 was the solution, and so was x is equal to 2. Once you have all this information, to answer the inequality, you can graph your two sides and see where one is greater than or less than the other. So the way I have this listed again is I put for y1 just the horizontal line 5, and then for y2 I entered in the absolute value of 2x plus 1. And this is the picture that popped up. So I want to know, where is this graph less than this graph? So that's where's the absolute value of 2x plus 1, where is that lower than 5 if you're looking at the y values? And there's only two possibilities. It's either between these two values, or it has to be on the outside of those two values. So if I again start by traveling on the graph, okay, so I'm starting here. I'm on the absolute value of 2x plus 1, and clearly this is well above y is equal to 5. So I know I'm not talking about this portion of the graph. But the second I get here, okay, that's where they're equal. But if I travel to the right, now the absolute value of 2x plus 1 is below 5. And that remains true up until you get to this point here. That is enough information to say the solution has to be everything from -3 to +2. I'm just not going to include those two endpoints, just everything in between them. So I know that has to be the answer. I'll list that over here. Everything from -3 to 2. And if I just want to go back to the graph just to make sure there's nothing else. So I knew from here to here we were lower than 5. But the second you move past this point, okay, now the absolute value is bigger than 5 again. So I do not want to include any part of the solution from 2 to infinity. So I looked at the two graphs. I identified that this is the region where the absolute value of 2x was less than 5. And then that was everything from -3 to +2. And for the last example, same idea. I want to solve an absolute value inequality. It's just that this one is more complicated. But we're going to take the same approach as in the previous examples. It's always good to know where they're equal first. And like I said, we already solved this in the previous lesson. I know that this spot and this spot is where the two graphs are equal. One of those values was x is equal to 1, and the other value was x is equal to 4. So that's everything at 1 to 4. But the real question here is, where's the absolute value of 2x plus 1? Where's that greater than or equal to the absolute value of 4x minus 7? So, I went to my graphing calculator. I put for y1 the absolute value of 2x plus 1. For y2, I put in the absolute value of 4x minus 7. And to answer this question, so I'll start on this graph. This was the absolute value of 2x plus 1. This is definitely a lot harder to see, but all right, if I'm going to determine if we're either between these two values or on the outside, I'm going to just travel along until I can figure out where is this graph above this graph. So I don't really see a whole lot here because the blue graph is off the window. But as I start to move over here, okay, here's the absolute value of 2x plus 1 compared to the absolute value of 4x minus 7. Okay, this stuff is clearly well above this portion of the graph. So 2x plus 1 in absolute value is lower than 4x minus 7. So I know that's true for all of these points on the graph. I do not want to include any of this stuff. So here, I have 2x plus 1 in absolute value is less than the absolute value of 4x minus 7. Now, the second I get to here, they're equal. And if I cross over this point, I'm back on the absolute value of x plus 1. This portion of the graph is definitely above this graph. This is exactly what I'm looking for. I wanted to see where is the absolute value of 2x plus 1 above the absolute value of 4x minus 7. It's everything from 1 to 4, and including both of those points too. So that was from 1 to 4. And again, we could just be careful. I know it works for the points from this spot to this spot, but maybe I'll check going past 4 to see what happens. The second I move over this point, so I'm still on 2x plus 1 in absolute value, and if I compare it to this graph, okay, it's definitely lower. This is now less than the absolute value of 4x minus 7, so I do not want to include any of the x values here in my solution. So the answer was everything from 1 to 4. It was not stuff on the outsides of the two numbers, and that's it for this example.